I welcome you to another series of our videos. If you haven't subscribed, please ensure you do so. A 2.65 kg power line running between two towers has a length of 38.0 meters and is under a tension of 12.5 newtons. A. What is the speed of a transverse pulse set up on the line? B. If the tension in the line was unknown, describe a procedure a worker on the ground might use to estimate the tension. Alright, so the speed of a wave traveling on a stretched spring of a mass per unit length under tension F is given. So this is the expression. V representing the speed of a wave traveling on a stretched spring. So it's given by the square root of force, which is represented by F over the linear density, which is this is the linear density, which is a mass per unit length. So in our question, we've been given the tension or the force to be 12.5 newtons and the mass to be 2.65 kg and a length of the power line to be 38.0 meters. So with this information we can use the same information to answer the question at hand. So the force or the tension we have is 12.5 newtons, which we have substituted here. Then the linear density, we have mentioned that linear density is given by mass over length, which we have written here. So the mass is 2.65 kg, which is there. We have substituted there. Then the length is 38 meters. So when we punch on a calculator, we are getting our linear density to be 0.069736842. So that's our linear density. So now we will go forward by simplifying what is in this square root. So 12.5 divided by 0.06936842. So we are getting, when we divide, we are getting the square root of 100 and square root, then 179.245283. This is what we are getting. So at this point now, we will find the square root of 179.24583. So when you punch that on a calculator, we are getting the speed of a wave to be 13.3882568 meters per second, which we have written here. So this can be written in three significant figures to be 13.4 meters per second. So let's also look at question B. So question B is saying if the tension in the line was unknown, describe a procedure a worker on the ground might use to estimate. So the worker on the ground could throw an object such as a snowball at one end of the line to set up a pulse and then use a stopwatch to measure the time it takes the pulse to travel the length of the line. From this measurement, the worker would have an estimate of the wave speed, which in turn can be used to estimate the tension. So this is the procedure a worker on the ground can use to estimate the tension.